All right, here on the first page, simplify. We've got sine of theta times secant of theta. Secant we know to be 1 over cosine. So what I have is sine times cosine, which I know is sine over cosine rather, which is tangent of theta. And that is simplified. Cotangent is cosine over sine times secant, which is 1 over cosine. Cosines will cancel there. 1 over sine is cosecant of theta. Number 5, sine squared plus cosine squared. We know from our, oh sorry, I skipped number 3. Let me go back up to 3. Cotangent squared plus 1. We do know that from a Pythagorean identity as well. Cotangent squared plus 1 is cosecant squared. Just like I've mentioned several times on your test, when you get your test, you might want to write down your Pythagorean identity of sine squared plus cosine squared is equal to 1, and then derive the others. Derive the others, divide everything by sine squared, that gives you 1, plus cotangent squared over equals cosecant squared. And then the last one, if you divide everything in the first by cosine squared, you get tangent squared plus 1 equals secant squared. So that's why on number 3, where I have cotangent squared plus 1, I see that that's equal to cosecant squared. I'm finished. Okay, number 4, cosine over secant. You might want to think of secant as 1 over cosine, in which case I want to think of the numerator, cosine, as being multiplied by the reciprocal of the denominator, so cosine of theta over 1. And so I see that that's cosecant squared. Or I think I said cosecant, and what meant cosine. Cosine squared. Okay, number 5 now. Sine squared plus cosine squared. We know that that's 1. In the denominator, 1 minus cosine squared. We need to take that sine squared plus cosine squared and rewrite it so it says 1 minus cosine squared. If I subtract cosine squared from both sides, I will end up with sine squared of theta equals 1 minus cosine squared of theta. That's helpful to use here because 1 minus cosine squared is equal to sine squared. So I can replace the denominator with sine squared, and 1 minus sine squared can be written as cosecant squared of theta. Cosecant is 1 over sine. Tangent is sine over cosine, minus tangent, which is sine over cosine. It's not the only way to do this problem. You could have factored out a tangent if you preferred, and gone that route as well. Looks like here in the first, for the plus, those cancel out. We get 1 over cosine of theta, minus, we're going to get sine squared over cosine. I have a common denominator here, so I can combine that into a single fraction. 1 minus sine squared of theta over cosine of theta. If we went back up to that original Pythagorean identity and wrote 1 minus sine squared, we have to subtract sine squared from both sides. We're going to end up with cosine squared equals 1 minus sine squared. So now I know I can replace 1 minus sine squared with cosine squared. So I'm going to have cosine squared of theta over cosine of theta. We can cancel out 1 cosine from top and bottom, leaving us with just cosine of theta. Might have been faster to factor out the tangent, perhaps, maybe not. Okay, here we go. Number 7. Cosecant is the inverse of sine, or reciprocal of sine. Tangent, sine over cosine. And cancel out my sines, leaving me with 1 over cosine, which is secant. Number 8, sine squared over tangent squared. Perhaps we want to think of tangent squared as being sine squared over cosine squared. And I can think of the numerator, leave the numerator alone. But instead of multiplying by sine squared over cosine squared, I can multiply by cosine squared, or dividing, instead of dividing by the fraction, I can multiply by its reciprocal. And here my sine squareds can cancel, leaving me with cosine squared. of theta. Number 9, sine squared of theta, and then I can write cotangent as cosine squared of theta over sine squared of theta. Sine squareds cancel, leaving me with cosine squared of theta again. All right, number 10, cosecant squared minus cotangent squared. Look back up to our identities. We have one of them with a cosecant squared and a cotangent squared. If I were to have subtracted cotangent squared from both sides, that would have read 1 equals cosecant squared theta minus cotangent squared of theta. So I've arranged that identity in a way that I can use it here. That numerator has to equal 1. My denominator, 1 minus cosine squared, I've already rearranged that up here. We saw that 1 minus cosine squared was sine squared. So I can replace that, and that's equal to cosecant squared of theta. All right, and now we can go on to number 11, where we begin verifying. So on that left side, I'd probably write that as sine over cosine times cosine. Cosines cancel, leaving me with sine of theta equals sine of theta, which I have completed. Number 12, cosecant. That's 1 over sine of theta times cosine of theta. When you combine those together, that's cosine over sine, which we know to be cotangent of theta. Number 13, 1 minus sine squared. If I look back up here a little bit, I've already solved this. 1 minus sine squared is cosine squared. So I can go ahead and put cosine squared of theta in the numerator there, over cosine of theta. And now cosine squared over cosine, we can cancel out a cosine from both, leaving us with cosine of theta equals cosine of theta. Number 14. I'll probably leave the numerator alone. And once again, just like the last problem, we see that we have in the denominator 1 minus sine squared, and up here we said 1 minus sine squared is cosine squared. Sine over cosine is tangent, so sine squared over cosine squared must be tangent squared of theta equals tangent squared of theta. Check. Number 18, I'm going to, actually, rather than distribute, I see I have a 1 minus sine squared. I keep using that. That's like the third problem in a row. I had a 1 minus sine squared. And we discovered that 1 minus sine squared is equal to cosine squared. So I can replace that, actually. I'm going to replace tangent with sine over cosine as well. So I have sine over cosine times cosine squared notice I can cancel out this cosine and one of the cosines up there, leaving me with sine of theta cosine of theta equals sine of theta cosine of theta. Ta-da! And lastly, number 16, as I look in the parentheses, cosecant squared plus secant squared, those are not in the same trig identity, so I'm going to go ahead and distribute my sine squared. So sine squared times cosecant squared. Well, cosecant squared is 1 over sine squared. Plus, now, sine squared times secant squared, which is 1 over cosine squared. Over here, sine squareds cancel, giving me 1. Sine squared over cosine squared, that's tangent squared. Take a look up here. For 1 plus tangent squared, it's one of our identities, it's equal to secant squared. So I'm going to replace 1 over tangent squared, or 1 plus tangent squared, with secant squared of theta. Secant squared of theta equals secant squared of theta. We are finished with the front side.